Dear grade 10 student, today is a new chapter. The scalar product is a scalar quantity of two vectors. We use the scalar product not only on mathematics problem but also in physics problems. Let's start by a geometric definition of the scalar product. For this, take two vectors u and v, non-zero of the plane, and let theta be the angle between these two vectors. By definition, the scalar product or the dot product of these two vectors is defined by u dot v is equal to the norm of the vector u times norm of the vector v times cosine the angle between these two vectors. Application: u and v be two vectors such that the norm of u is equal to 2 cm and the norm of v is equal to 5 cm, where the angle between the two vectors u and v is equal to pi over 3. We need to calculate the dot product of these two vectors. Apply the rule of the dot product. We find that u dot v is equal to the norm of u times norm of v times cosine the angle between these two vectors is pi over 3, and replace the norm of u and the norm of v and theta by their values. We get 5. In this paragraph, we need to study the sign of the scalar product when the scalar product is positive or negative or equal to 0. In the figure A, the angle between the two vectors u and v is an acute angle less than pi over 2. Then, cosine of this angle is positive, so the dot product of u and v is positive. In the second figure, the angle between the two vectors u and v is an obtuse angle greater than pi over 2, so cosine of this angle is negative, therefore the dot product is negative. In this figure, the two vectors u and v are collinear having opposite lengths, then the angle between the two vectors is equal to 180, and we know that cosine of 180 is equal to minus 1, therefore u dot v is equal to minus norm of u times norm of v is negative. In the figure D, the two vectors u and v are collinear having same length, then the angle between these two vectors is equal to 0, and we know that cosine of 0 is equal to 1, so u dot v is equal to norm of u times norm of v is positive. In the last picture, the two vectors u and v are perpendicular, and we know that cosine of pi over 2 is equal to 0, then u dot v is equal to 0. Application: consider the square ABDC of side 2 cm. And the question is to calculate sum of the dot product. Let's start by the first question. To calculate the dot product between the two vectors AB and CD, we find that the two vectors are parallel having same sense. Then the angle between these two vectors is equal to 0. Apply the rule of the dot product. AB vector dot CD vector is equal to AB times AC times cosine 0, and AB CD is equal to 2, then 2 times cosine 0 is 1, so it's equal to 4. The second question is to calculate the dot product of the two vectors AC and DB. We find that these two vectors are collinear having opposite sense, then the angle between these two vectors is equal to 180, so apply the rule of the dot product. AB AC vector dot DB vector is equal to AC times DB times cosine 180, and we know that AC is equal to 2 and also DB is equal to 2, and cosine 180 is equal to minus 1, then the dot product is equal to minus 4. In the third figure, we need to find the dot product of the two vectors CA and CB. We find that the angle between these two vectors is equal to 45. Then the dot product of CA dot CB is equal to CA times CB times cosine 45. We know that CA is equal to 2, and we need to calculate CB. The triangle CAB is a right isosceles triangle at A, and CB is the hypotenuse of this triangle. Then, by according to Pythagoras theorem in right isosceles triangle, CB is equal to CA radical 2, then CB is equal to 2 radical 2, and cosine 45, we know that is equal to radical 2 over 2, then the dot product CA vector dot CB vector it's equal to 4. In the question 4, we need to calculate the dot product between the two vectors CB and AB. We find that these two vectors are not having the same origin. Transfer these two vectors on two vectors having same origin. AB is equal to minus BA vector and CB is equal to minus BC vector. So, the dot product of AB and CB transfer AB to minus BA and CB to minus BC, minus times minus equal to plus. Then we get two vectors having same origin. Apply the rule of dot product BA vector dot BC vector is equal to BA times BC times cosine the angle between these two vectors and replace each side by its values, and we get that BA times BC times cosine 45 is equal to 4. Remark, it's better to put the two vectors on the same origin. 5. We need to calculate in the final question here the dot product of AD and BC. We find that these two vectors are perpendicular since they are diagonals in square, so the dot product of these two vectors is equal to 0. In this paragraph, we need to find the angle between these two vectors. For this, take U and V two vectors and let theta be the angle between these two vectors. The dot product is used to find the angle of two vectors. We know that by definition the dot product of U and V is equal to norm of U times norm of V times cosine theta. Then to find the angle theta, first find the cosine of this angle. Therefore, cosine theta is equal to the scalar product U dot V over the multiplication of their norms. Application. Find the angle theta between the two vectors AB and AC, where AB is equal to 5, AC is equal to 4, and the dot product of these two vectors is equal to 10 radical 3. Apply the rule of the cosine. We get cosine theta is equal to the scalar product of AB and AC over the multiplication of their norm, and replace by the values. We get AB scalar AC, it's equal to 10 radical 3 over 5 times 4, then cosine theta equal to radical 3 over 2. Finally, to find theta, use the calculator. Theta is equal to cosine minus 1 of the answer, then theta is equal to pi over 6.